Students, before the study of simple cubic cell, we should know why we are studying about the characteristics of simple cubic cell. So it is related to the crystallography. And you know that crystallography is nothing but it is the study of different types of structure of solid. So basically, solid are the crystalline and non-crystalline. So here we are studying the characteristics of simple cubic cell. It is related to the crystalline solid. The crystalline solids are such types of solid in which all the atoms are regularly arranged, or in simple language we can say it is a regular arrangement, one by one. You know the best example, that is a tray of eggs. So if you observe the tray of eggs, there you can see the one egg, another egg, third egg. So row wise and column wise, all the eggs are well arranged. So this is the crystalline type of structure. So students, in this topic we will study characteristics of simple cubic cell. So simple cubic cell, what is the main purpose that we are studying about the simple cubic cell? The main purpose of simple cubic cell is to study the basic structure. With the help of the basic structure of any solid, we can understand their total properties, how it is, what is the bonding level, what is their viscosity, what is their different types of property that we will study here. So here you can observe or you can see the diagram of simple cubic cell. So basically you must know that in simple cubic cell there are the 8 corner atoms. Here 1, 2, 3, 4, 5, 6, 7, 8. So this simple cubic cell, it's just like the simple cube. You know that the cube. You know that in cube there are the total 6 faces. Similarly, here also the 6 faces. Top view, first face, bottom, second, right side, third, left side, fourth, front side, fifth, and back side, sixth. So in this way, in simple cubic cell, there are the 6 faces. And in simple cubic cell, there are the 8 corner atoms, 1, 2, 3, 4, like that. And bottom 5, 6, 7, 8, like that. So now, to study the basic structure of simple cubic cell, you must know the characteristics of simple cubic cell. And what are that characteristics? So one by one we will study. Here number 1. The first characteristics of simple cubic cell is volume of unit cell. So student, how we can find the volume of this simple cubic cell? Means it is a unit cell. So it is nothing but the volume of cube. There are the 3 dimensions: x dimension, y dimension, and z dimension. So in this way, all that dimension, this is the first dimension, side A, second dimension, side B, third dimension, side A. So here V is equal to A into A into A. It gives the A. Means volume of simple cubic cell is nothing but the A. Similarly, second characteristics, effective number of atoms in SCC. So before doing the study of the effective number of atoms in simple cubic cell, what do you mean by effective number? So student, effective number means the particular unit cell, how many atoms they consume. How it is possible? So this unit cell is regarding to the space lattice. So once again the question will arise, what do you mean by space lattice? So in simple language, we can say that the space lattice is nothing but the one unit cell which is attached with the another unit cell, second unit cell which is attached to the third unit cell. Similarly, offside, similarly downside, all the unit cell, they are connected to each other. So in that case, what is the effective number of atoms? So effective number of atoms, to calculate this term, we should know the formula. That formula is what? It is the fraction of each corner atom multiplied by total number of corner atoms. So student, here if you observe, the fraction of each atom. So how many atoms are here? There are the total 8 corner atoms. So what will be the fraction? Look, 1 of 8, it will be the fraction. Multiplied by total corner atom, it will be what? 8. So 8 will cancel. So you will get Z is equal to 1. So what do you mean by Z is equal to 1? Z is equal to 1 means effective number of atom in simple cubic cell is 1. So similarly, third characteristics, atomic radius. So student, before going this simple cubic cell, we already discussed all corner atoms are in spherical in nature. Means first atom it looks like sphere, second atom it also looks like sphere, third atom it also looks like sphere, fourth atom means all at corner atoms are looks like the sphere. So that's why the atomic radius it will be given. How? So here this first atom if you will enlarge it with the help of electron microscope. So you will observe that this single spherical atom which is attached to the another spherical atom like that. So similarly these two atoms they are nearly attached to each other, and with the help of that you will get the atomic radius. So if you observe this distance to this distance, it will give the A, that is called as the lattice constant, which is equal to, so see this distance to this distance, this is the radius. Again, from this center to this distance, it is the radius. So R plus R, it will be what? 2R. So that's why student, A will be written in the form of 2R. So R is equal to A by 2. So this is the final atomic radius which is obtained in simple cubic cell. So with the help of this, you can easily calculate what is the atomic radius in terms of value. Similarly, coordination number. So student, coordination number means it is the how many total number of atoms which are equal distance from that specific atom. So for this, you have to imagine, suppose this unit cell is connected to the another unit cell. So what happens? This is the specific atom. This specific atom, so another atom will connect here, another atom will also connect here, this another atom will also connect here, this atom will also connected here. So all the atoms are connected. But what is our condition? Our condition is how many number of atoms which are equidistant or equal distant. So student, from this specific atom, this is the first atom, second atom, third atom, fourth atom, fifth atom, sixth atom. So total here 6 atoms which are equidistant, and that's why coordination number will be what? It is a 6. Okay. Similarly, next point means characteristics, atomic packing fraction. So atomic packing fraction is how many number of atoms they are attached or they are packed to each other. They are packed to each other means this atom is attached to each here. This atom will also attach with this. This atom will also attach with this. So how many total number of atoms in percentage form? In percentage form, we have to find out how many packing fraction is there. So that's why the word is here atomic packing fraction. So formula is Z into volume of atom upon volume of unit cell. So Z is nothing but the effective number of atom, volume of atom. So here atom is looks like the sphere, and that's why it is just like the volume of sphere. And you know the volume of sphere is nothing but 4 by 3 pi r cube upon a cube. So here if you put the value r is equal to again this a by 2, it will be a cube by 2. So it will solve it. So you will get 0.52 or it is called also 52%. Means 52% area or region will captured by these atoms in this unit cell. 52% area means these atoms are joined to each other. So overall 52% area is captured or occupied by this atom in unit cell. So here is the what atomic packing fraction. And next, void space. Sir, what do you mean by void space? So void space is nothing but the vacant space of the atom after capturing or after occupying the space. Means these atoms is attached with another atom. This atom is also attached with another atom. So how many atoms they are occupy the region, and after that we have to think how many part or how many fraction or how many percentage region that will be vacant. So formula is here, void space is equal to 1 minus ampere, and here 1 minus ampere is 0.52, or it will get 0.48, or you can say that 48%. Means after the occupying this atom, 48% area is vacant. 48%. So in this way, you can also calculate or find out the void space. And now, what is the density of simple cubic cell? So there is a standard formula. Here, rho is equal to Zm upon Na into A cube, where Z is equal to effective number of atom. Here is the atomic weight of this atom, and Na into A cube. So if you put that value, you will get m upon Na into A cube. So in this way, students, you can understand how the characteristic is helpful to identify any solid, and especially the simple cubic cell. But application point of view, the polonium is the best example of the simple cubic cell. But you know, the polonium is the radioactive element, and its tendency in our universe is very, very less. So generally, simple cubic type of cell is not to be more utilized, but it is studied in various laboratory, various syllabus. So that's why we are studying about the characteristics of simple cubic cell. So in this way, simple cubic cell gives the history, gives the property, gives the application of any types of solid. With the help of that, you can identify, you can find out the types of cell.